Have you ever looked at a big network, one that stretches across multiple floors, maybe even different buildings, and wondered how it all just works? How everything stays connected? Well, the secret sauce is a core networking idea we're going to unpack today: the Cisco Trunk Link.
Okay, so let's picture it. You've done the smart thing, right? You've split your network up into virtual LANs or VLANs. You've got sales on one, marketing on another, engineering on a third. It's awesome for keeping things organized and secure. But you've just hit a wall. How in the world do you get a computer in the sales VLAN to talk to a server in the engineering VLAN if they're plugged into totally different switches?
And that's where this awesome concept called trunking comes in. It's the solution. Think of it like we're about to build a special, high-tech bridge that lets all of our separate little VLAN islands talk to each other, even when they're on different switches.
So what exactly is a trunk link? Honestly, the best way to think about it is like a multi-lane superhighway for your data. See, a normal switch port is just a single-lane road. Only traffic from one VLAN can use it. But a trunk port? That thing is a highway with lanes for all your VLANs, carrying all that traffic at the same time, all while keeping it perfectly organized on its trip between switches.
So how does this highway system keep all the cars, all the data, from crashing into each other? The magic is something called tagging. When a piece of data from, let's say, the sales VLAN needs to cross over to another switch, the first switch slaps a special digital tag on it. It's kind of like putting a brightly colored label on a moving box. That box then zooms across the trunk link highway. When it gets to switch B, the switch just reads the label and says, "Aha, this one's for sales." It rips the tag off and sends the box to the right department. It's simple, but it's brilliant.
All right, that's enough theory. Let's actually get our hands dirty and see how you build this thing on a real Cisco switch. We're going to configure our trunk right now, one command at a time.
It really just boils down to three main tasks. First, we got to tell the port its only job is to be a simple layer 2 switch port. Second, we have to define the language, or the protocol, it's going to use for that tagging we talked about. And finally, we just tell it, okay, your mode is now trunk. That's it. So command number 1 is just switch port. Now, here's a key detail. You really only need this command on what we call a multi-layer switch, one that can do layer 3 routing. If you're on a simpler layer 2 only switch, you can skip this. But for those more advanced switches, this is the crucial first step where you tell the port, look, I know this switch can route, but your specific job is just to switch frames at layer 2. Got it?
Next up, encapsulation. This is where we pick that tagging language. Now, a long time ago, Cisco had its own way of doing things called ISL. But today, the whole industry uses one open standard, and that's 802.1q, or as we all call it, .1q. So we lock that in with the command switchport trunk encapsulation .1q.
And that brings us to the last and, frankly, the most interesting step. We've got a choice to make. Do we want to be the boss and just force this port to be a trunk, no questions asked? Or do we want to let the switches on either end of the wire chat with each other and figure it out on their own?
This choice gets to the heart of two different ways of thinking in network administration. Do you want total manual control, or do you want to let automation do the work? Let's break down how this plays out.
Okay, so on one side of the coin, you have the static trunk. You type switch port mode trunk, and that's it. Done. You've explicitly ordered that port to be a trunk, forever. It's clean, it's clear. On the other side, you've got Cisco's Dynamic Trunking Protocol, or DTP. This is the automation path, where the switches actively send out little messages to each other to try and negotiate whether they should become a trunk or not. Now, DTP itself has a couple of different, let's call them personalities. A port set to dynamic desirable is the extrovert. It's actively reaching out, saying, hey, you over there, let's form a trunk. But a port in dynamic auto mode, that one's the introvert. It's totally cool with being a trunk, but it's just going to sit there and wait for the other side to start the conversation. It's basically saying, yeah, I'll be a trunk, if you want to.
And this is exactly where people get into trouble. Take a look. If at least one side is desirable, the extrovert, it kicks off the conversation and a trunk always forms. No problem. But look at that last line. This is the one that gets everybody. If both sides are set to the passive dynamic auto, which by the way is often the default setting, they just sit there, each one politely waiting for the other to say something first. And the result? The conversation never starts, and a trunk will never, ever form.
So the key takeaway here, and it's so important it's worth saying directly, is this. If two passive ports are connected, neither will ever initiate trunk establishment, and the trunk will never be formed. That right there is a classic problem that trips up so many people when they're starting out.
Okay, so let's say we've got our trunk configured.
We're not done yet. Any pro will tell you the job isn't over until you do two things: verify your work and then lock it down with one final professional touch.
The command you are going to live and breathe as a network admin is show interfaces switch port. It gives you a full status report on everything that port is doing, and it's how we're going to find out if our configuration actually worked.
And that is what you want to see. Right there in the output, that beautiful line, operational mode trunk. That's the confirmation. It means our link is up, it's running, and it's acting as that multi-lane highway for our VLANs. We did it! But wait a minute. Let's go back to our static config, the one where we type switch port mode trunk. We forced it into being a trunk, so it's totally static, totally secure now, right? Well, not quite. There's a little hidden detail that we really need to talk about. If you look real close at that same output, you'll probably see a line that says negotiation of trunking on. And you're thinking, what? That's right. Even though we manually force the mode to trunk, the port is still sending out those DTP negotiation packets by default. And from a security perspective, that's not good. An attacker could potentially use those packets to try and trick our switch. We need to shut that down.
And this right here is the difference between a good config and a great one. This is the pro tip. You add one more command, switch port non-negotiate. This little command does one simple, powerful thing. It tells the port to stop sending DTP packets, period. It makes your static trunk truly 100% static.
So now, when we run our verification command one last time, we see perfection. Negotiation of trunking off. Our trunk is working, it's fully configured, and now it's properly secured. That is a job well done. So this all brings us back to that fundamental question. Are you a fan of the automation that DTP offers, even with its potential pitfalls? Or do you prefer the absolute control and clarity of a static configuration? There are arguments for both, but knowing the difference is what really matters. So, how will you build your network?